Water walls. Astronauts' minimalist liquid life support. Sound of a gentle rhythmic hum, perhaps a subtle clink of metal. Imagine for a moment being an astronaut. You're floating, weightless, in the quiet hum of a spaceship, hundreds of miles above Earth. Around you, a labyrinth of pipes, wires, and intricate machinery forms the very backbone of your existence. Every breath you take, every sip of water, every moment of safety from the harsh vacuum outside relies on systems that are complex, heavy, and meticulously engineered. There's a constant, almost imperceptible thrum of pumps, filters, and purifiers, the silent guardians of life in an alien environment. This constant reliance on intricate mechanical marvels often brings with it a sense of vulnerability. What if a pump fails? What if a filter clogs? In the unforgiving expanse of space, simplicity is not just a preference, it's a profound advantage. And it's this very idea, the elegant power of simplicity, that has led engineers to conceive of something truly remarkable, something they've playfully, yet aptly named, the water walls experiment. At its heart, the water walls experiment is an exploration into the fundamental behavior of water in microgravity. We're used to water flowing, pouring, splashing here on Earth. But in space, it transforms into a mesmerizing, almost sentient blob. Its surface tension takes on a new significance, allowing it to hold together in ways that defy our terrestrial intuition. The core concept is to harness this unique property by containing water within a series of flexible water-filled bags. But these aren't just any bags. They are designed to form literal walls, adaptable and dynamic structures that could serve a myriad of functions within a spacecraft. Think of it, not rigid bulkheads, but shimmering, living membranes of H2O. Engineers aren't just thinking incrementally here. They're envisioning a complete paradigm shift in space habitation. Their audacious hope is that these water walls might one day replace some or even all of the critical life support systems currently in use. Imagine the implications for spacecraft design, for mission duration, for the very future of human presence beyond Earth. Let's delve into the specific applications, because this is where the genius of the water walls truly shines. First, consider the mundane yet vital aspects of daily life: waste management. On current missions, gray water from sinks and showers and black water, human waste, are processed by complex, power-hungry systems. But what if you could dedicate a water wall bag to each? A gray water bag acting as a dynamic reservoir and perhaps even a passive filtration system through biological processes embedded within the water itself. And a black water bag, containing and treating waste in a compact, contained, and incredibly efficient manner. The elegance lies in its simplicity, reducing the number of moving parts and the sheer volume of intricate plumbing. Then there's the air we breathe. Our spacecraft atmospheres require constant purification, removing carbon dioxide and regenerating oxygen. The water walls concept proposes a bag dedicated to air purification. Picture a living wall of water, perhaps infused with specific biological agents or even simple chemical compounds, silently absorbing exhaled CO2 and potentially releasing fresh oxygen. It's a closed-loop system, far more integrated and less reliant on high-maintenance machinery. Next, and perhaps most fascinatingly, is the idea of edible algae. Space travel demands sustainable food sources. What if one of these water walls could be a self-sustaining farm, a bioreactor cultivating nutrient-rich edible algae? A living pantry, providing fresh food, and contributing to oxygen production, all within a transparent, dynamic wall that literally forms your living space. It's food security, air regeneration, and a visual connection to life, all in one. And finally, perhaps the most critical application for humanity's deeper forays into space: radiation shielding. Beyond Earth's protective magnetic field, astronauts are exposed to harmful cosmic radiation. Current shielding is heavy, bulky, and often inefficient. Water, however, is an excellent radiation attenuator. A water wall, strategically positioned around crew quarters or sensitive equipment, could provide a lightweight, adaptable, and highly effective shield against deadly radiation. It's a liquid suit of armor, protecting precious lives and equipment on long journeys to Mars and beyond. What makes this concept so profoundly revolutionary is its incredible simplicity. Today's life support systems are a marvel of engineering, but they are also a testament to complexity. Pumps, valves, filters, membranes, sensors, all working in intricate harmony, each a potential point of failure. The water walls, by contrast, dramatically reduce this mechanical and technical overhead. The most significant mechanical piece on these water walls would be the humble water pumps, designed simply to move the water where it is needed, to a faucet, to a purification module, or to replenish a shield. That's it. Fewer parts mean less weight, less power consumption, and ultimately greater reliability in the harsh vacuum of space. The water walls experiment is more than just a scientific inquiry into fluid dynamics. It's a profound vision for the future of human exploration. It speaks to a new frontier of ingenuity, where our most advanced technological solutions are found not in ever-increasing complexity, but in a return to elegant, natural principles. By understanding and harnessing the unique properties of water and microgravity, we might just unlock the key to truly sustainable, minimalist, and safer life in space. Imagine a future where our spacecraft feel less like intricate machines and more like living, breathing extensions of ourselves, where the very walls that define our living space are also the systems that sustain us. It's a future where space travel is not just possible for a select few, but becomes more accessible, lighter, and safer for all who dare to dream of the stars. The Water Walls Project reminds us that sometimes the most sophisticated answers are found in the simplest elements, gracefully adapting to the most challenging environments. What do you think of this elegant approach to space life support? Does the idea of living inside walls made of water spark your imagination? Share your thoughts in the comments below. If this journey into the future of space exploration resonated with you, consider giving this video a like and subscribing for more stories that explore the incredible intersections of science, technology, and human ingenuity. Your support helps us bring these thoughtful explorations to life.